Thank you for watching this video. This is the case study which I'm going to do on the machine learning recommendation algorithms, how it works and how are all the different algorithms and what algorithms exactly we do in this machine learning recommendation. As this algorithm is really has been like really big asset for the big corporations like Netflix, YouTube, which has like developed algorithm over the time using that user data and has provided that data to recommendation. And this let me tell you, this recommendation algorithm completely works on the data of the user provided. If the data is more, the algorithm accuracy and precision is more. So as you have must have experienced this, that YouTube has like recently went on the congressional hearings of the court for the data capturing and fetching of the data from the user. Now they have introduced new algorithm that you can have pause the data to stop let machine learn from your data. But this comes to your choices, this has come to your preferences, what you prefer over the time. So here I begin with the presentation. So this is the EDA1. So this is the explorating data analysis first part. So this is about the non-null values. Data is super clean. So you can see that this data has no null values. You can see that there are the complete the data is completely clean. The data has like three columns as a integers and one column as a float. And data this is a small data entries which has like 9,742 entries, and the bigger data has 32 million rows. So that data has rows which can be covered on the 96 GB RAM or maybe more than that, which the system cannot perform data on a 32 million of rows. So we need to go and reduce the data size and potentially the data CSV file itself. So you can see the data is clean. So this is the first part, exploring. Second is exploiting data, where we have come across where we need to go with the ratings. So ratings, this is the basic plot of between the ratings of what is the frequency of rating and over the period of rating, like over the ratings, what like exactly how many percentage of the movies which exist with this rating, like users has provided this rating for this movie. So you can see that you can say overall from this data set by viewing this viewing by seeing this graph, that there are good movies in this data sets. Fairly, like people have suggested really fairly good movies in this data set. So you can go ahead and go over the good movies. So what are the good movies? So top 10 movies are like the 1993 the movie Chandelier List, the Terminator 2, which is super famous, 1991, Braveheart 1995, Jurassic World 1993, Star Wars 1977, Matrix 1999, Silence of the Lambs 1991, Pulp Fiction 1994, Shawshank Redemption, that is 1994, and again Forrest Gump, that is 1994. So there he this is the just data exploration with the rating. I just plotted the data with the average of average of these movies, the number, and the plot is in the ascending order, just as the top 10 movies. So how do we calculate average? With just a statistic step which we do for a average, and we aggregate and we group by the, and group by adding the group by, we can connect two blocks to with each other with matching, just as we do in SQL. This is this just we are doing with data frame using pandas data frame. So as you can see, there are like 10 unique values which are 10 unique titles and 8 unique values for 8 unique genres. And average rating is overall 5 star, and no missing value, zero missing value, and you can see movie ID for corresponding. So this is aggregation, group by function, and inner join, the left join with the rating and movies data set. This is the central tendencies of this data sets. So again, this is just rating data set. So as you can see that the central tendencies of this data set are fairly good. So here we do aggregation of the two title two two data sets that you see that the title and genre. And so Toy Story has like genre has adventure animation. So this is genres are generated by aggregation of these two data sets, and that columns, that aggregation, that count is assigned to that corresponding title. So as you can see, Toy Story has adventure, animation, children, comedy, fantasy. Jumanji has adventure, children, fantasy. Rope Year Old Man has comedy, romance. Waiting to Exhale has comedy, drama, romance. Father of the Bride Part 2 has the comedy. So this is the aggregation which we do in statistic to get the result. This is where the NLP goes. If you haven't heard about this word TF-IDF, this is the most important part where you begin with, and for the recommendation algorithm. This is where you get to know what exactly count of the words in the document and what are the least count of the words document. This is the unique way to calculate, and the number you see are the number which we see for the English words and the Chinese words. So I'll later on I'll show you the code as well. So these numbers are TF-IDF. TF means term which is frequent, term which is frequent, and inverse document frequency. Inverse document frequency works as the term which is frequent is equals to the term which is how many times the term has appeared divided by the total words of total words. But while calculating IDF, you must have thought like how do we consider the and ads, they. So these are basic words and they have no much meaning about it. So how do we consider? So there is a way we can pass the word stop English, which is stops the English common words and excludes them and focuses on more important word which makes more sense. So with this ITF-IDV is most productive method I came across with the case study, and I introduced this is the first time I came across TF-ID. I've been through entire research about TF-ID and learned about TF-ID, which is the most important part of NLP, which is like beginning of NLP, not just exactly NLP, but this is where you can understand NLP in a in more like a fundamental sense. The next we have the shape of this matrix shape. 9742 is the shape. Then second, we have the cosine correlation of the NLPs. So this is where we begin with the correlations of the matrix as we do in the statistics. But this is the correlation of the NLP cosine, which not only connects with the column but also tells how many similarities with the current order. So it automatically goes on and compares the similarity of the matrix value to the other correlated matrix value of the other columns. So this is the core advanced level of correlation method which we use in pandas. Then next is the consign is the pulsar. Why I'm saying that? Because this result recommendation for Toy Story is achieved by using the cosine. The cosine is has the simulation which compares all the correlated values metrics and similarities and gives you the recommendation for Toy Story. So let's say if a user likes Toy Story, it gives you Ants 1998, Toy Story 2 1999, and Adventure of Rocky and Bullwink from 2000, Emperor New Groove 2000, and Monsters from 2001. So this is you can pass for 10 value and you will get 10 recommendation. So this is where the cosine comes in the picture. Next, we check the double check for the model. What is the efficiency of the algorithm which we use? So there are the three steps we check the algorithm SVD on three splits. Now the fold you see is the same data set which is divided in the three parts to check the efficiency and the deviations within the data set. The deviation you see is here is 0.0052, and the for third that for the for all fold you can see the fit time is it's much more deviated, much more less deviated. Mean value for fit time is also much more less. So you can compare this, and RMC value is root mean square error, and MAE is mean actual error, which is less than 0, which is less than 1. And you can predict upon this that the standard deviation is less than 1, and even if it is above 1, it won't matter because standard deviation is much lower here, 0.05. So I would just go for this model, and can rely on this model, that this model will predict everything that to the point. Next, testing. So here I have tested well performance. I observed that top 5 model I went for that. I passed user ID 10, and for user ID 10, whoever it is has liked few movies, and according to that he has been suggested 5 movies. Some like It Hot from 1959, Lawrence of Arabia 1962, Goodfellas 1990, and Raging Bull 1980s, and Amelie, A Fabulous Destiny, the Amelie Plotinthle. So this, with this ending, I'd like to share what are the latest advancement here, that the Gemini AI has released the Veo 2 and the Genie 2, which are the most advanced model from these Gemini Google. So this is the most advanced model. And recently OpenAI has released a video converter and video translator on the spot, just like the NLP. This is now the new NLP, or the video NLP, you can say. With this note, I'll just hang up on this presentation. This was the presentation about the case study of which I have done on the recommendation system and the algorithms which I have explored. I go upon now to the code which I have implemented to get this algorithm. So here you can see I have installed surprise dataset, which I had actually downloaded the dataset, but I anyway installed this. And here you just directly use the dataset term. Like you can see the requirements are satisfied here. The ratings, you just load the dataset into the data frame, and then you print it, and then you just check the head upon it, and you just go ahead and check the values of the timestamp and the ratings for it. Just checking, exploring the data just for no reason. This has no meaning, but just exploring. And this is just exploration of no null values, missing values. If we had any null values, we would have just gone for average and just put all the average values into the missing columns and the rows and cells, whatever. So we just use. And this is the usage memory. It has usage for 228, which is much more higher actually. Some of the data sets which comes within the range. Another, we can have a distribution of movie. We have seen this in the frequency table, in the presentation. This is the frequency. So this is the rating count, which is just a statistical method to group by, which we do in SQL. This is the data frame, so we need to group by with the DF methods, and you can see the top 10 most watched movies. Then we have this average of these movies, and with the average ratings, we go ahead and go see the top 10 movies in the different genres. The genres are assigned to the title. And then here we can see that the summary which we get from the standard mean deviations. This is the complete central tendencies measure, which can see rating, mean, count, and standard deviations. So these are less than, like, not much bigger deviations. I have seen like a lot of big deviations, 300, 700, 2000. And compared to that, this standard deviation is much more low, and which we can rely on, that this good data set. We can see the deviation is much more low. Then next we see genres, and then we just go ahead and just check for the color aggregation, which we do replacing, and this not listed if they will combine the genres in single string if the dataset uses. And as a delimiter, let's replace with the space. So as this dataset has this delimiter, we are just replacing with the space, and we are setting regular expression as false. because this is not a regular expression. Each row corresponds to a movie, each column generates related term. So this is the TF-ID which I was talking about in the presentation, that this is really important, on which we go ahead and stimulate cosine simulation, which is not just cosine, it is a correlation. In simple terms, it is a correlation matrix, but in a more advanced manner, as you can see. Then we just go ahead and go with the movie title, indexing mapping of movie ID and title. And here we see that this is just a recommended content recommender, which has no like big, it's not a big algorithm, but this is just a demo of how it works. We just pass title and number of recommendation. So what it does is goes on the title index and it search for the index, and what value cosine simulation has for that index. It's actually collecting all the simulation score, and again it's passing it from in sorted way, and we are getting a sorted recommendation list. So this cosine value is not just a correlated matrix which we see in the basic statistic. This is advanced level of cosine simulation in NLP, which not only just checks the value but also gives the similarity value in a more precise way. Then we can put it in the ascending order, and then we render it. So here are the renders. So we now trend set and test set, we separate this train set and test set differently. And then we do algo svd n factors 50, random state 42, and this is the where the algorithm comes in picture. And here we go, predictions algo test, t-test stage, and RMC score we get. Just we check if the error is much more higher, so that we cannot have trust on this. Then again we go and see for every fold, and for each fold it has performed really well. The standard deviation is much more lower, like really insignificant, it's almost zero. And we can rely on this data set. Again we go and print for user ID 10 and movie IDs 50, like some movies. So this is the data sets. So this here this algorithm it comes in the picture. This is the main algorithm which Netflix and YouTube is earning in billions. So this is the algorithm. You can see that the user ID is given, and then the user can have and can watch this movie. He will love it. So that's upon the